Hi, I'm Paul Battaglia, and this is section 4.3, right triangle trigonometry. I've brought along Gabe and Brittany today, and they're going to talk to us a little bit about how to structure this lesson from a teaching perspective. Brittany, how do we deal with the idea that students might be somewhat familiar with right triangle trigonometry?
So I like to just give a short review. So say, yeah, we've seen this, and kind of, do you remember SOHCAHTOA? You know, and go through just a few examples, the simple ones, and then like to go on to more application-based ones.
Okay.
Yeah. So as you're reviewing, that really almost lays a little bit of a foundation for really working with the identities, and then from there, maybe starting to see some of the identities that occur throughout this section and the next few chapters. So what I like to do, maybe after reviewing the definition of the 6 trig functions, is maybe give my students some sort of guided or discovery-based worksheet. Where they can actually discover the identities on their own.
Right.
And I have them do this just by using the definitions that are given earlier in the section.
Right, and that's great. And you know what we're doing? We're kind of bridging the ideas that we talked about previously a little bit with the unit circle, looking forward a little bit, you know, into identities, which we won't talk about for another chapter, but we're at least starting to get them to see the idea, you know. Maybe go over some applications is to, yes, talk about some of the familiar ones. You have the ladders leaning against the wall, right, and the flag poles and things of that nature. But students may have even seen those before. So how do we jazz it up a little bit? How do we excite them about something that they may have seen? Well, we can have them build an inclinometer. And we have one here. Let me tell you some of the materials that you would need to build this, and I'll tell you what you can do with it. So it's a kind of a rough device, and that's okay. And what we'll have here is a piece of paper. I use just an 8x11 piece of paper. We have a protractor. I would say you definitely look for a protractor that has a hole in there so you can thread some string through it. And then some type of a weighted instrument, like it could be a washer, this is a lug nut, something that is going to weigh the string down a little bit. And what you'll do is you'll simply thread the string through the hole, attach the lug nut or washer to the string, tie the ends up, and students can do this on their own, and then tape this piece of paper to the protractor. So what do we do with it, right? Well, I mean, the idea behind right triangle trigonometry is angles of elevation, angles of depression, and how they relate to sides of triangles, right? And so what we can do is we can go outside, we can walk around the building, and we can now measure certain things and even bring a tape measure into it and say, well, let's look at some known variables. Let's say that we are standing 10 feet away from this stop sign, right? Let's measure the angle of elevation to the top of the stop sign, and then let's actually use math, right triangle trigonometry, to figure out how tall the stop sign really is. And that's just one example, but let your kids be creative and let them kind of, if you're allowed, let them go wherever they can. I know at my school we've gone even out to like the fields, the sports fields, and we've gone to the bleachers and things of that sort. And it really gets them out of their element. It gets them using something that is familiar to them, maybe in just a little bit of a new way. You know?
Interesting.
Is it perfect? No, you know, but that's okay. I think that's part of it. I think that's part of the experimentation process.
The one other thing with the applications is when they're converting, they have to remember in their calculator to check degrees and radians.
Yep, great idea. Yeah, because you know it's so common, I think, for a lot of students actually to simultaneously be taking physics perhaps with a pre-calculus course, and so they're used to being in degrees in one class and radians in another. So definitely make sure that what you're working with is appropriate in your calculator. I hope you found these tips helpful and that you find much success in section 4.3.